Introduction, and a quick overview of the concept. Have you ever wondered what it would be like to travel through time? To step into the past and witness historical moments firsthand? Or perhaps leap into the future and see what awaits us? Time travel has been a fascinating concept in science fiction for decades, but could it ever be a reality? In this video, we'll explore what science says about time travel, dive into the theories of Einstein, and consider what challenges lie ahead. What is time? Define time and why it's such a mysterious concept. To understand time travel, we first need to understand time itself. Time, as we experience it, seems to flow in one direction: past, present, future. But what exactly is it? In physics, time is often referred to as the fourth dimension, alongside the three dimensions of space: length, width, and height. Together, these four dimensions make up what we call space-time. However, unlike the spatial dimensions, we only seem to move in one direction through time. This raises an interesting question. Is time an illusion? Could it be possible to move backward and forward through it, just as we move through space? Einstein's theory of relativity. Explain how time and space are connected through Einstein's work. When it comes to the scientific foundation of time travel, we need to look at Albert Einstein's theory of relativity. In 1905, Einstein introduced his special theory of relativity, which completely transformed our understanding of time and space. One of the key ideas in this theory is that time is not absolute. It can stretch and shrink depending on how fast you are moving. This concept, known as time dilation, has been proven by experiments. For instance, atomic clocks placed on fast-moving airplanes show a slight difference in time compared to clocks on the ground. The faster you move through space, the slower you move through time. Then came Einstein's general theory of relativity, which added gravity to the mix. According to this theory, massive objects like stars and planets can warp the fabric of space-time. The stronger the gravitational pull, the slower time moves. This is why time moves more slowly at the surface of the Earth than it does in space. Wormholes, a bridge through time? One of the most exciting ideas related to time travel is the concept of wormholes. A wormhole is essentially a shortcut through space-time, a tunnel that could, theoretically, connect two distant points in the universe. If wormholes exist, they could potentially allow us to travel not just through space, but through time as well. Imagine this. Instead of taking a long journey from one star to another, you could step through a wormhole and arrive almost instantly. And if the two ends of the wormhole are in different points in time, you could travel to the past or future. However, there are several challenges with this idea. First, we've never actually observed a wormhole. They remain purely theoretical. Second, even if we could create one, keeping it stable enough to travel through is another story. Wormholes are thought to collapse quickly, and the energy required to stabilize them might be beyond our reach. Even if time travel were possible, it comes with some strange and confusing problems. One of the most well-known is the grandfather paradox. Imagine you travel back in time and prevent your grandfather from meeting your grandmother. If they never met, then one of your parents would never have been born, and by extension, neither would you. But if you don't exist, how could you have gone back in time to begin with? This paradox raises deep questions about the nature of time and causality. Some theories suggest that time travel would create alternate timelines or parallel universes, where different versions of events play out. In this case, changing the past wouldn't affect the present you came from, but would instead create a new branch of history. Other solutions to time travel paradoxes include the idea that the universe might prevent such contradictions from occurring. This is called the self-consistency principle, which suggests that any attempt to change the past would be doomed to fail. Is time travel to the future possible? While traveling to the past seems fraught with paradoxes, traveling to the future is much more straightforward according to physics. As we mentioned earlier, time dilation means that time moves more slowly for someone traveling at close to the speed of light. In theory, if you could travel fast enough, say, on a spaceship moving at a significant fraction of the speed of light, you could leap into the future. Here's how it would work. If you spent a few years traveling at near light speed, you might return to Earth to find that decades, or even centuries, had passed. This form of time travel has actually been observed on a very small scale. One philosophical theory that challenges our understanding of time is the block universe theory. According to this idea, the past, present, and future all exist simultaneously. In other words, time is like a landscape, and we're just moving through it. From this perspective, the future is already out there, waiting for us to arrive. This could have interesting implications for time travel. If all moments in time exist at once, then traveling to the past or future might be more like traveling to a different location. The block universe theory also raises questions about free will. If the future is already determined, can we change anything about it? The possibility of time machines have been a staple of science fiction for generations. But is it possible to build one? Some scientists think it might be. One proposal involves the concept of a closed time-like curve, which is a path through space-time that loops back on itself. If you could create a closed time-like curve, you could, in theory, travel back to the point where the loop begins. One theoretical time machine idea is based on rotating black holes, also known as Kerr black holes. If you could travel around a Kerr black hole at just the right speed, you might be able to move backward in time. However, getting close to a black hole comes with significant risks. Another idea involves using cosmic strings, which are hypothetical objects left over from the early universe. By wrapping these strings together and moving them at high speeds, it might be possible to create a time loop. But again, this is all speculative. Final thoughts. Is time travel really possible? So, is time travel possible? The answer, as with many things in science, is that it's complicated. While traveling into the future is theoretically achievable, going back in time presents a host of paradoxes and challenges. From wormholes to cosmic strings, scientists have proposed some fascinating ways to make time travel a reality. But for now, it remains in the realm of theory and imagination. The mystery of time travel captivates us because it challenges our understanding of reality. As our knowledge of the universe continues to grow, who knows? One day, time travel might move from science fiction to science fact. Until then, we'll keep exploring the possibilities and pondering what might be. Conclusion: time travel, whether possible or not, forces us to rethink our place in the universe. Could we ever unlock the mysteries of time itself? Perhaps the answer lies in the future, or maybe it's already in the past. Thanks for watching.